Okay, functions, this is the second part of the circular motion video. It's going to be example 2 and example 3 in the notes, which correspond to homework 2 and homework 3 on your homework. So example 2, they're kind of a little less straightforward than the first ones. In example 2, we have a 16-inch diameter tire. Okay, now notice that says diameter, not radius. Is making 500 revolutions per minute. Find the linear speed of that tire in miles per hour. Okay. Now a couple things to note on this problem. One is that, again, they gave us the diameter, which is not the radius. Okay. The second is they gave us revolutions per minute, but we want our final answer in miles per hour. Now, we're not given anything about miles, and we're not given anything about hours, so we're going to have to convert those, because we're given inches and we're given minutes. But let's start with what we can find. We can find the linear speed. We can find the velocity in inches per minute, and then we'll convert it to miles per hour when we're done. Okay. All right, so first up, again, we're going to need to find the arc length. We're going to have to find S. Okay. So how far is this tire actually going? Well, remember, it's going to be the radius times theta. Okay. The radius is 8. Okay, it's half of the diameter. Because again, they gave us a 16-inch diameter, so our radius is going to be 8. And just like before, our theta is going to be 2 pi, which means all the way around the circle, times how many revolutions does it go? How many times does it go all the way around the circle? Okay. Well, in this problem, it's 500. Okay. So our arc length is going to be 8 times 2 times 500, which is 8,000 pi. Okay. Inches. Now again, 8,000 pi inches doesn't really mean much to me. So what you can do is you just do 8,000 times 3.14. Which is 25,120 inches. Alright, so that is the arc length. That's how far this tire traveled. But it's in inches, and first of all, we need to find the linear speed, which is v. Okay. So again, what we know is we know inches and we know it's per minute. So that's how many inches it goes per minute. So our velocity here, our linear speed, is 25,120 inches in 1 minute. That's our linear speed. That's the linear speed if it asked in inches per minute, but it doesn't ask that. It asks miles per hour. So we're going to have to get rid of the inches and convert it to miles, and we're going to have to get rid of minutes and convert it to hours. Okay. So you've probably done this in science. You've probably done it in math before. But we need to, it's called dimensional analysis. We need to get rid of these units. So let's start with minutes. Okay. I have minutes, but I need hours. So you have to think of some conversion rate to get minutes into hours. Well, I know that there's 60 minutes in 1 hour. Okay. When you're doing this, you always want your labels, your units, to be opposite of each other so they cancel out. Okay. If you multiply something over minutes times minutes over hours, the minutes part are going to cancel out. So now what am I left with? I'm left with inches over hours, but I want miles over hours. So I have to convert inches. Well, I know that there are 12 inches in a foot. Okay. So I'm going to need, since I already have inches on top, I'm going to need to put the inches part on the bottom. So I got 12 inches in 1 foot. So now you got inches on top, inches on the bottom. Those are going to cancel out. So now what am I left with? I'm left with feet over hours, feet per hour. Again, I want miles per hour. So I'm going to have to do one more conversion to get feet into miles. And this one, some of you probably memorized, some of you probably haven't. There's 5,280 feet in 1 mile. Okay. Now, since I already have feet on top, I'm going to have to put the 5,280 on the bottom. Okay. That's for 1 mile. All right, now feet on top, feet on the bottom cancel out, and the units that I'm left with are miles over hours, miles per hour. So when you're multiplying these, all you have to do is multiply across the top, multiply all the way across the bottom. So 25,120 times 60 times 1 times 1 is 1,507,200 miles in 1 times 1 times 12 times 5280, which is 63,360 hours. So this is close, but we want miles per 1 hour. Okay, not miles per 63,000 hours. So all you have to do is divide those two numbers, and that's going to give you in miles per hour, and you should get about 23.8. Okay. Again, miles per hour. Okay, so for example 3, so example 2 is linear speed, example 3 is going to be back to angular speed. Okay. A circular saw blade with a diameter of 9 inches rotates at 2,800 revolutions per minute. Find the angular speed in radians per second. Okay. Now again, we're going to have to convert because we're given revolutions per minute and we want it in per second. Okay. All right, now one thing in the last problem, we had to deal with it saying diameter. Okay. In angular speed, the diameter and the radius don't really matter because it's just saying how many times does it go around in a circle. Okay, so the radius doesn't matter, so this is kind of like a trick. We actually don't need diameter anywhere in this problem. So that's not important. The 9 inches isn't important. That's not going to come into play. What is going to come into play is we need to figure out, again, the angle, the radians. How many radians is it going around? To do that, we're just going to have to, again, we know there's 2 pi radians in a full rotation. And figure out how many full rotations it takes. And it takes 2,800 revolutions per minute. 1 revolution is all the way around the circle. So it's going to be 2 pi times 2,800. So we got about 5,600 pi radians in 1 minute. Which is going to be your angular velocity. Okay, your lowercase theta, your curvy w. So we know our angular speed is 5,600 pi radians per minute, per 1 minute. But again, we want it to say seconds. We want per seconds. So this one's not as hard as the last one. It's just one conversion. We have to go, we have radians and we want radians, but we have minutes and we want seconds. So we're going to have to do how many seconds are there in a minute. Okay. Well, since minute is already on the bottom, we need minute to go on top. Okay. And I know that 1 minute is also 60 seconds, which means the minutes and minutes are going to cancel out, and you're going to be left with the units of radians over seconds. Radians per second. Okay. Since these are all ones, all you really have to do is 5600 times 3.14 divided by 60 seconds. Okay. And you should get about 293.2 radians per second. Now, what does that mean in context? Well, a full circle is about 6.28 radians. Okay. So this is going pretty fast, going around the circle a lot of times in 1 second. All right, and that's example 3. It goes along almost identically with the problem 3 in the homework. Okay, so that's going to be posted on Google Classrooms. If you want to check that out, it'll give you a couple days to work on this.